I'd like to welcome Cynthia Dwork to our Fireside chat today and to your MSRAI Distinguished Lecture coming up in the next hour. Cynthia is the Gordon McKay Professor at Harvard University, the Radcliffe Alumni Professor at the Radcliffe Institute for Advanced Study, and affiliated faculty at Harvard Law, as well as a distinguished scientist at Microsoft Research. Welcome.
Thank you. It's good to be here.
I wanted to start off with thinking about your background and the breadth of topics you've worked on in computer science. I wanted to ask you how you got into computer science, and then how you chose the problems, the breadth of problems that you've worked on, from cryptography to privacy and now fairness.
So that's a broad question. I got into computer science initially on a lark when I was applying to college. My mother said, maybe you should consider applying to the engineering school. I was applying to Princeton. I said, why not? And I checked the box. And so I started in computer science. At that time, it was electrical engineering and computer science. And I pretty much liked my first year. I started the circuits course in my second year, and I didn't like it. And I switched out of the School of Engineering and wouldn't come back until they they waived the requirement for the circuits course. And then in junior year, I met formal languages and automata theory, and I just fell in love. When I was ready to graduate, I decided I wanted to continue my studies, and I went to Cornell and studied theory. And my first work was in distributed computing, and I did that for a number of years. I was heavily influenced by Nancy Lynch, who had come from MIT to give a talk when I was a graduate student at Cornell. And I postdoced for her. And at a certain point, we needed, so in distributed computing, you're often talking about good guys computing in the presence of some bad guys that are trying to disrupt the computation. And it's very natural that you might use cryptography to hide information from the bad guys. And what we discovered was that the kinds of cryptography that existed, the cryptography that sort of captured privacy from a passive eavesdropper when messages are going back and forth, is not the same as what you needed when the adversary is playing the same game as all of the good guys. So we needed basically a different kind of cryptography. And so I ended up studying cryptography, and I got into, developed something called non-malleable cryptography together with Moni Naor and Danny Dolev. And then I loved crypto, and I did that for quite some time. And eventually, sort of around the year 2000, I was talking to the philosopher Helen Nissenbaum, who studies philosophical issues that arise in the context of new technologies. And Nissenbaum was studying, what does privacy mean in public, and what does privacy mean when we have video cameras all over the place? And I got very intrigued, and I looked for a piece of the privacy puzzle that sort of theoretical computer science and cryptography might be able to say something about. And crypto had developed a lot of language for talking about partial information, and that seemed like a good beginning. And that is how I got into privacy and led to differential privacy eventually.
That's fascinating. So these topics that you've been working on, from both privacy and then now fairness, these are age-old problems, right? That philosophers, ethicists, and the legal scholars have been thinking about for centuries. And now you've brought, I think, a very new perspective, the computer science, a theoretical perspective. I'm kind of curious. Since you've been doing that, how has that perspective, you think, shaped or affected the broader discussion about privacy and now, I guess, how people are thinking about fairness?
So I don't think that what we've done in privacy-preserving data analysis really addresses large questions about how people feel about privacy. It was a very specific corner of the general privacy puzzle. We did look a bit to the legal and the philosophical literatures to help us try to articulate specific privacy concerns. I mean, legal scholars and philosophers will try to find very precise language to capture things that people feel and why they feel the way they do. So we got help from them more than vice versa. In the fairness domain, I think that there's some chance that the data analytic tools can help shine spotlight on how people think and where there are unfairnesses and biases. That so we may get some help on the bigger questions from the technology.
So I love that you mentioned the interplay between computer science and other disciplines and borrowing ideas from them and now perhaps feeding back a little as well and trying to figure out the solutions to these challenges together. How do you go about engaging with people outside of our home discipline?
How do I go about it? So I guess research like any other kind of research. So there's some sort of starting point. I'll be, like in the privacy domain, my interest was piqued by Nissenbaum. In other areas, in fairness, I could start immediately looking for people who think about questions of distributive justice, who think about gender bias in medicine, who think about racial bias. And when you have some successful conversations with people, they're sort of kind and refer you to their friends. So I've been tremendously lucky and had the opportunity to talk to a lot of people this way. So networking, I guess.
Yes.
Yeah, and reading, a lot of reading.
Do you think computer science as a whole does enough of this type of engagement, or just the right amount? Or I'm curious.
So I think that computer scientists more than ever have to start thinking about ethics and being educated about ethics. That computer science is moving into a position of tremendous power, and with that comes ethical responsibilities. At the same time, everybody has his or her own strengths and interests, and for the people who only want to study one kind of thing deeply, I certainly wouldn't want to derail them. So I think naturally we're going to have a big mix, but I do feel that students should be educated about ethics. And Harvard is moving in that direction in computer science as well. So I had an ethicist come and speak and work with the class in the class that I taught most recently, and several other people are doing this.
When we were talking earlier this morning, you mentioned that you thought that the work you're doing now in bias is a lot more challenging in some ways than your earlier work on differential privacy. I'm kind of curious if you could say a little bit more about that.
Sure. So I think that defining bias is much, much tougher. So the first thing that you want to do if you want to have a technical solution that helps with at least some aspect of a bias problem is to define what bias is, or to define what is the unfairness that you're trying to combat in your particular corner of the technological universe. So when we were talking about privacy, and we kind of had narrowed it down to privacy-preserving data analysis, which is a much smaller scope than privacy in general, We could think about different definitions of privacy, and we came up with one which is rather robust, and it captures many intuitions about what constitutes privacy in data analysis. And so, you come up with it, you develop methods that ensure it, and there's not controversy about what you're doing. It may or may not do everything, but it does what it says it does, and people don't argue that what it says it's doing is a bad thing. It's only a good thing. Now, when it comes to fairness, things go all over the place. So, for example, you could say, well, I want to have a classifier, and I want it to be, I want to ensure what we call demographic parity. That is, the fraction of people in a given demographic group that are, let's say, receiving a positive classification should be the same as this fraction of this demographic group in the population as a whole. Is that fair or isn't it? Is affirmative action fair or isn't it? If you are looking at cases where you're trying to make predictions and you're going to have some error because the future is not knowable, do you require equal false positive rates and false negative rates across groups or not? And what are the consequences of these things? So it's a lot of natural definitions, natural desiderata are mutually exclusive. What do you do about that? What can you ask your system to do when these various things that you want are mutually exclusive? You have to come to some kind of a social agreement as to what you mean by fair and what's appropriate for your setting. And I'm starting to understand that this is a fundamentally political process. And my politics education is just beginning.
So do you think the role of the language and framework, the theory, behind fairness is about showing the options to policymakers and legal folks, or what role do you see?
Okay. So first of all, I should mention there is a definition that I like, although it too has all sorts of problems. And the definition that I like is what we're calling individual fairness, which says intuitively that given a particular classification task, individuals who are similar with respect to that classification task should be classified similarly, should have similar probabilities of positive classification, for example. And, of course, a problem with that is, well, how do we determine who is similar to whom for this task? What is the metric? What is the measure of distance, of similarity or dissimilarity between two people? And even if you had your hands on a metric, how do you know that it's the right one? So an example that I like to think about is, let's say that we have a very nice news organization, and we're looking to hire people to our news organization, and so we want to predict who is likely to succeed at the news organization, and we have a very crisp definition of success. You stay 3 years with the company at least, and you have at least one promotion in those 3 years. So success is well defined. So then you want to say somehow that if you have two people who are similarly likely to succeed, then they should have the same probabilities of getting a job offer or similar probabilities of getting the job offer. Now, so now let's change the problem, and we say, well, maybe it's not such a nice news organization. Maybe it's a news organization that has historically been hostile to women. So now, for two equally talented individuals, one male and one female, it may be that the man is more likely to succeed than the woman because the atmosphere is hostile. So wait, should the metric be capturing likelihood of success, or should the metric in fact be talent? In the nice news organization, talent predicts your success. In the nasty news organization, talent is insufficient to predict success. So you need to exercise thought and judgment about what should the classifiers be doing and how do you use them. On the other hand, When you actually formalize the problem, it becomes abundantly clear that the issue is hostility in the work environment. So there's something that's gained immediately from the formalization of the problem.
So you brought up the issue of these algorithms accidentally learning from society's biases and amplifying them potentially in the decisions that they make. And that's one source of bias that I hear people talking about. And I also hear people talking about data biases, where the data that's used to train an algorithm is perhaps an insufficient representation of what goes on in the world. Maybe it's biased through some selection mechanism or collection mechanism. Do you see these two types of biases as two sides of the same coin, or do you think that they're different and require different approaches to address?
So I'm not actually clear what you mean in your first example. In fact, when you were saying your first example, I thought that you meant the second. That is, that the biases are imbibed in the mother's milk of the training data. Mm-hmm. So then what's learned, it's not an accident that it's learned. It wasn't the intention of the algorithm designer to teach the algorithm to be biased, but the biases are just brought in there from the historical training data.
Let's see. So I was thinking about the two kinds of biases I was thinking about was one where there's an existing bias in an organization, like the company, versus another one where the organization is not biased, but perhaps the data that you collected about employee success was selected in such a way to not be representative of that organization.
So clearly a biased organization is giving rise to what I would call biased historical data. Mm-hmm. And so probably, if I'm interpreting your question correctly, the answer is yes, these are two sides of the same coin. Right.
Yeah. I guess in one case you have opportunities to go and collect more data, and the other one you can't without fixing the organization.
So that's another, you're alluding to something else, which is just lack of representation. Mm-hmm. And lack of representation presents its own problems and historically has presented bad problems. Mm-hmm. And one can collect more data, and one can also sort of be smarter about exploration-exploitation trade-offs. Mm-hmm. And so there's starting to be a nice literature on this sort of thing in the fair algorithms world. But I think also that, if I'm not mistaken, economists were also aware of this. So you have two populations, a minority population and a majority population. You know the majority very well. What kinds of incentives can you offer a bank for giving loans to the minority population so that that population becomes better known? Mm-hmm. So these questions are not entirely new. These questions of lack of representation are not entirely new. And I think we should be thinking a lot in terms of what sorts of things can we do to encourage the increasing of the data sets and balancing out so that we get much more informed views? And how do we bring in experts on different populations and include them in the discussion of what constitutes fair and what are the right criteria to be using for the different groups? I think that I know that there's some interest in having, say, classifiers that suppress the information of the demographic group, and my guess is that, or not my guess, we know specifically that there are situations in which doing this leads to reduced utility, that having context allows you to make better judgments. Mm-hmm.
Where do you think the future lies in fairness? Do you think that we'll make a significant headway in the next few years from either a practical or a theoretical point of view, or do you think that that it's a long ways off yet, given the politics and the social aspects of challenge to the problem?
I think real progress on the mathematical side will be relatively rapid. That I'm seeing just in the last couple of years, a real gathering of strength and a plethora of new ideas and variations on the definitions that try to bridge the individual versus the group in very exciting ways. There are also some extremely intriguing approaches coming up in the deep learning community. So, I think that this is going really well. I don't believe there will be an alternative to having discussions that bring in politics and ethics and economics and so on. And I think that the charges to these communities are going to go up, and you're going to say, we need help with this, that, and the other thing. So I think things will make progress, but I don't see yet our way to finding a single crisp definition of what fair is that will really capture what we want all the time from an algorithm, a fair algorithm, and that will behave very well under what we call composition. We haven't spent any time talking about these very important questions of, if you have a system that has a bunch of pieces, each of which is fair, what happens, what can you say about fairness of your system in toto, altogether? And in other scenarios, in cryptography and in differential privacy, people know how to talk about composition and ensure nice composition properties. But in the fairness domain, things are much more difficult, and initial results are very negative, and we have to work hard to ensure fairness together. So
that's great to hear. I think we're out of time, and your talk is going to be coming up soon. Thank you very much, Cynthia, for coming. It's been a pleasure talking with you.
The pleasure's been mine. Thank you so much.